So now we're up to the last question of the quote unquote easy questions. Question 5. Has it taken you less than 65 minutes to do this? Let's hope so. So a company manufactures smartphone and developed a new battery that has a longer lifespan than the traditional. From the date of purchase of a smartphone, the distribution of the lifespan of the new battery is approximately a mean of 30 months and a standard deviation of 8 months. Okay, it gave us a mean and a standard deviation. Ding, 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 normal model, normal model, normal model. For a price of $50, the company offers a 2-year warranty of the new battery for customers who purchase a smartphone. Okay, 2 years, 24 months. The warranty guarantees that the smartphone will be replaced at no cost to the customer if the battery no longer works within 24 months from the date of purchase. So, first thing, in how many months from the date of purchase is it expected that 25% of the batteries will no longer work? Okay, so I've drawn a normal model. Yes, it's ugly, but that's okay. There's 30. There's 22. That's 30 minus 8. The standard deviation is 22. Now, the 25th percentile is going to fall somewhere in here. So I know that the 25th percentile, or the first quartile, is about a negative 0.67. I know it's a normal distribution because they gave us a mean and standard deviation. So I go inverse norm. Oh, how do I get to inverse norm, Pruitt? Well, let me show you how to get there. So I go second distribution, inverse norm. It's where the normal models are. Inverse norm. Okay, we're trying to find what percent or what's the value that at that 25th percentile right there. So here to the left. So my area is 0.25. Whoops, what happened to my 2? My mean was 30. My standard deviation was 8. I want to the left of this value, and I paste it, and it tells me that's about 24.6, or in other words, 24.6 months, which is a little over 2 years, right? A little over 2 years. Now notice what I did. I wrote that on here. I put the area, I put my mu, and I put my sigma. What you also could have done on this, you could have set up the z-score and solved for the z-score. These are 2 different ways of doing the same problem. I called it I and 2I just to show you the different ways, and I'll do it again on part B. I know the 25th percentile is a negative 0.67. So I set that equal to x, what I'm trying to find, minus the mean divided by the standard deviation. This is a z-score. 25th percentile is a z-score of a negative 0.67, approximately. So I multiply times 8, add 30 to that, and I get 24.64 months. Either of these 2 answers is acceptable. Okay, part B. Suppose that one customer who purchased the warranty is selected at random. What's the probability that that customer will require replacement within 24 months? Okay, so we got a new model. Same thing, same normal looking. We can first find this as a z-score. We can do z equals 24 minus 30 divided by 8, which is a negative 0.75. If we do that, then we can say second distribution, 2. Okay, we're finding from negative 0.75 or 24 months to the left. So that's negative that. Or really, we can look at it this way. We can call that 0 if we're going to do a normal CDF. My upper would be 24. That's 30. That's 8. And we paste it, and we get 0.2265. 0.2266. I rounded that 5. I don't know why I rounded that. Oh, I know why. Yeah, this was 0.2265 here. On this one, it's 0.2265. On this one, if we do the z-score of a negative 0.75, we can go to the table. If you prefer, you could go to the z table. If I can find my z table. There we go. Okay. We can go to our Z table, which they give you on the test, and go negative 0.701234. We get this, 0.2266. You can use the table. This is a negative 0.75 right here. This is 0.70, 0.71, 0.72, 73, 74, 75. And that number is 0.2266, which they're really close to each other. So we can solve this one two different ways. Either way is acceptable. Now, we have, this is the probability that it's going to fail within 24 months. We then look at part C. The company has a gain of $50 for each customer who purchases a warranty but does not require a replacement. That's good. The company has a loss or a negative gain of $150 for each customer who purchases a warranty and does require a replacement. So what is the expected value? Well, the expected value is the success times the amount of gain. Well, success on this problem is 1 minus the loss, the 0.2265 or 0.2266, whichever you pick. I went ahead and went with these two. So that's my P, that's my success. This is my failure. Success, I multiply times $50 plus my failure times of a negative 150 times the probability of failure. And I add those two together and I get $4.70. Now, if I would have used this number, 0.2266 times a negative 150 plus the complement of this is 0.7734 times 50, and I get $4.68. So on each of these, I've given you two different examples of how to solve them. These two should be easy for you. Expected value, we seem to forget because we haven't done it very much. All right, that question took a little bit over 8 minutes. So question 5, the last one, hopefully you can get part of it. Maybe you can get all 3 parts of it. So you should have spent about 60 to 65 minutes, hopefully less, doing the first 5 questions.